The next topic is Zener Diode. So a Zener Diode is a silicon junction diode which is operated under reverse bias and arranged to break down when a specific reverse bias voltage is applied to it. I'll repeat again. A Zener Diode is a silicon junction diode which is operated under reverse bias and is arranged to break down when a specific reverse bias voltage is applied to it. So it is a special purpose semiconductor diode named after its inventor C. Zener. So it was invented by C. Zener. So due to its reverse breakdown, it is used as a voltage regulator. I'll repeat again. Due to its reverse breakdown, it is used as a voltage regulator. So this is the symbol of Zener diode. So this is the symbol of Zener diode. So Zener diode is fabricated by heavily doping the both P and N sides of the junction. Due to this, depletion region is very thin. I'll repeat again. Zener diode is fabricated by heavily doping the both P and N sides of the junction. Due to this, depletion region is very thin and consequently the breakdown of the junction will occur at very low reverse voltage on the other hand. So a lightly doped diode has a higher breakdown voltage. I'll repeat again. A highly doped diode has a higher breakdown voltage. The next topic is IV characteristics of Zener diode. So I have written a graphical representation here. So this is the graph of the Zener diode or the IV characteristics of Zener diode. So here it is seen that when applied reverse bias voltage V of the Zener reaches the breakdown voltage Vz. I'll repeat again. When the reverse bias voltage V under the breakdown reaches the breakdown voltage Vz, that is V when it reaches to Vz, breakdown voltage Vz of the Zener diode, there is a large change in current. So there is a large change in current. In other words, we can say that Zener voltage remains constant. The voltage remains constant even though the current through the circuit, the current through the circuit varies over a wide range. So the current varies for a wide range here. This property of the Zener diode is used as the regulating supply voltages, so they are constant. I'll repeat again. So when the applied reverse bias voltage reaches the breakdown voltage, okay, so there is a large change in current. So in other words, we can say that Zener voltage remains constant even though the current through the Zener diode varies over a wide range. This property of the Zener diode is used for regulating supply of voltages so that they are constant. As you can see that at a particular voltage, until here the voltage is increasing, but after this particular voltage the current has increased. So it is a peculiar character which can be observed in Zener diode. The next topic is internal field emission or field ionization. So the emission of electrons from the host atoms due to the high electric field is known as internal field emission or field ionization. I'll repeat again. The emission of electrons from the host atoms due to the high electric field is known as internal field emission or field ionization. The electric field required for field ionization is an order of 10 to the power of 6 volt per meter. So, I'll repeat again. The electric field required for field ionization is in the order of volt per 6 volt, 10 to the power of 6 volt per meter. The next topic is Zener Diode as a voltage regulator. So, this is the circuit of the Zener Diode. Here, the unregulated DC voltage is connected to the Zener Diode through the series resistance RS. Okay, then such that the Zener Diode is reverse biased. So, it will be reverse biased now. So, if the input voltage increases, the current through RS and the Zener Diode also increases. I will repeat again. If the input voltage increases, the current through RS and Zener Diode also increases. This increases the voltage drop across RS, but voltage drop across the Zener Diode remains constant. This is because in the breakdown region, Zener voltage remains constant even though the current through the Zener Diode changes. Similarly, if the input voltage decreases, the current through the RS and Zener Diode also decreases. I'll repeat again. If the input voltage decreases, the current through the RS and Zener Diode also decreases. This decreases voltage drop across RS, but the voltage across the Zener Diode remains constant. Thus, any increase or decrease in the input voltage results in increase or decrease in voltage drop across RS without any change in voltage across the Zener Diode. So, thus Zener Diode acts as a voltage regulator. I'll repeat again. Any increase or decrease in the input voltage results in increase or decrease in decrease of voltage drop across RS without any change in the voltage across the Zener Diode. Thus, Zener Diode acts as a voltage regulator. The next topic is optoelectronics junction devices. The semiconductor diodes in which charge carriers are generated by photons are called as optoelectronics junction devices. I will repeat again. The semiconductor diodes in which charge carriers are generated by photons are called as optoelectronics junction devices. So, we shall study the functioning of the optoelectronic devices in this chapter. We shall study few opto. So, the optoelectronic devices which we study in this chapter are light emitting diode, which is also called as LED. The next one is photodiode, and the third one is solar cell, which is also called as photovoltaic device. The next topic is light emitting diode, which is called as LED. It is a semiconductor diode which emits light when it is forward biased. I'll repeat again. It is a semiconductor diode which emits light when it is forward biased. So, this is the representation of LED. So, this is the representation of LED here. So, the next topic is the function or the working principle of LED. For that, we need this circuit. Okay, so this is the circuit. So, here, when the diode is forward biased, I told you the LED works under forward bias itself. So, when the diode is forward biased, electrons are sent from N to P and the holes are sent from P to N. I'll repeat again. When the diode is in forward bias, the electrons are sent from N to P and holes are sent from P to N. At the junction boundary, the concentration of minority carriers increases compared to the equilibrium concentration, and these carriers recombine with majority charge carriers. So on recombination, the energy is released in the form of photons. So photons, on the other hand, with the energy equal to or slightly less than the band gap, are emitted. When the forward current of the diode is small, the intensity of light emitted is very small. As the forward current increases, intensity of the light increases and reaches to a maximum. Further increase in the forward current results in decrease of light intensity. So LEDs are biased in such a way that light emitting efficiency is always maximum. I'll repeat again. LEDs are biased in such a way that light emitting efficiency is made always maximum. The next topic is applications of LED. So this LEDs, they are used almost everywhere or in each and every field. So usually these LEDs, they are used in indicator lamps in cars, bikes. So in automobile industry, we make use of this LEDs as a indicator lamps. So then the next one is we use this LED in remote control of TV. Yes, we use this LEDs in TV remote controls. Okay, so the next one is we use this LEDs in traffic signals. So in traffic signals we make use of this LEDs. So the next one is we use this LED in optical fiber communication devices. Even in optical fiber communication devices we use this LEDs. And these LEDs are most commonly used in calculators and watches. So all your calculators and most of your digital watches, they make use of this LEDs. Even in burglar alarm system, which is used in banks. So here they make use of this LEDs. So white LED can be used as lighting purpose. So in your houses, you people might be using LED bulbs which is of white LED. So even for the lighting purpose, this LED is used. So you have to note one thing, what that is, LEDs that can emit red, yellow, orange, green and blue light are commonly available in market. The next topic is advantages of LED over incandescent lamps. So we have replaced this incandescent lamps over this LEDs here. So most of us at home or even in the office or everywhere, we are making use of this LEDs more than incandescent lamps. So most of the people, they are not using this incandescent lamps because this LEDs, they are more advantageous than incandescent lamps. So I'll tell you a few advantages of this LED over incandescent lamp. So the first advantage is low operational voltage or less power. So the LEDs consume low voltages or low voltages to on and off. So they make use of very low current and low voltages. So the next one is fast action and no warm up time required. So this LEDs, they are very fast. They can be operated very quickly. So the next one is long life and ruggedness. So this LEDs, they have very long life when it is compared with incandescent lamps. So this LEDs, they have very long life. So the next one is fast on and off switching capability. So they can be used as fast switching on and off capacities. So the fast on and off capacity of the LED is more when it is compared with the incandescent lamp. So the next one is emitting light is nearly monochromatic. So the emitting light, by the LED is nearly monochromatic. The next topic is semiconductor laser diode, which is also called as SLD. So here it is a specific type of LED which emits coherent light as in laser. So I'll repeat again. It is a specific type of LED which emits coherent light as in laser. It works on the principle of laser. Like laser itself, it emits coherent light. So this is why for this purpose itself it is called as semiconductor laser diode. The next topic is photodiode. It is a semiconductor diode which produces electric current when light is incident on it. I'll repeat again. It is a semiconductor diode which produces electric current when light is incident on it. That is called as a photodiode. So this is the representation of photodiode. Okay. So the photodiode is operated on reverse bias condition. The photodiode is operated on the reverse bias condition. Next, I'll explain the function and the working of this photodiode. So this is the circuit and this is the IV characteristics here. So here, when the photodiode is illuminated with light, that is photons with energy greater than the energy gap of the semiconductor, then electron-hole pairs are generated due to the absorption of photons. So I'll repeat again. When the photodiode is illuminated with light, that is photons with energy greater than the energy gap of the semiconductor, then electrons hole pair is generated due to the absorption of photons. The diode is fabricated in such a way that the generation of electron hole pairs takes place in or near the depletion region of the diode. Due to electric field of the junction, electrons and holes are separated before they recombine. Electrons are collected on N side and holes are collected on P side, giving rise to an EMF. So when the external load is connected, current flows. The magnitude of the photocurrent depends on the intensity of the incident light. So the IV characteristics of the photodiode of the illuminated intensity is as shown here. So this is the IV characteristics here. So this is the I1, I2, I3, I4 currents. So the I4 is greater than I3 and I3 is greater than I2 and I2 is greater than I1 here. The photoelectric current is directly proportional to the intensity of light. You have to remember this thing. The photoelectric current is directly proportional to the intensity of light. So there are certain applications of this photodiode. I'll tell you one by one here. So it is used to detect both visible and invisible light and to detect optical signals. I'll repeat again. It is used to detect both visible, invisible light and to detect optical signals. So then it is used in logic circuits. So this photodiodes, they are used in logic circuits. I'll tell you later in the class. So what this logic circuits are. And next, it is used to measure the intensity of light. So this photodiodes could be used to measure the intensity of light. The next one is, it is used as light meter in camera. So it is used as light meter in camera. So usually these photographers, they make use of this light meters. So the next one is, it is used in optical fiber communication. Yes, definitely this photodiodes, they are used in optical fiber communication.